Today we're going to look at sections 3.2 and 7.2 together. These sections are going to allow us to prove triangles congruent using 4 postulates. All right, so remember yesterday we talked about the idea of being congruent. So 2 geometric figures with exactly the same size and the same shape we can refer to as congruent. So notice that here we've got 2 triangles, ABC and DEF, okay? If I was to put one on top of the other, we should have the same size. It's definitely the same shape because they're both a triangle, so that would make them congruent. So yesterday we talked about if you have congruent triangles, you could name 6 different pairs of corresponding parts. 3 of them would be sides and 3 of them would be angles. My question here says, do we need all 6 corresponding parts to prove triangles congruent? So this time we're not given the triangles congruent. We're going to have to decide whether or not they are. My answer for you is no, we do not need all 6 corresponding parts in order to prove congruent triangles. All we're going to need are 3 corresponding parts in order to state that triangles are congruent. And it does matter in which 3 we choose, though. Okay, so that's where these postulates come in. Remember, a postulate is an unproved assumption. So these are things that you can assume based off of what I am telling you. So let's look at the 4 different methods to prove triangles congruent. We've got side, side, side. Okay, we can shorten that as just SSS. Okay, so as long as we can get 3 sets of congruent sides, then we've got congruent triangles. The second method would be side, angle, side, which we can abbreviate as SAS. The angle in between the sides we call the included angle. So you have to have the angle in between 2 sides in order to say side, angle, side. Our third method is angle, side, angle, or ASA. The side in between the 2 angles we call the included side. And then our fourth way is angle, angle, side, where we have 2 angles, but the side is not included. So looking at this picture, we're going to name the included angle from each picture. So based off of the markings on the left picture, because I have the 2 sides, 1 tick mark, 2 tick marks, notice that the angle that's in between them is angle G. So that's the included angle. If I look at the middle letter with the middle picture with the 2 segments that are marked, it is angle I that is in between them. That's the included angle. And if we look at the picture on the far right, based off of the 2 tick marks that are marked up, notice that it would be angle H that would be the included angle. So it's the angle that's in between the 2 segments. So if I gave you this triangle YES and I said name the included angle and I gave you the 2 segments, notice how in this first one, segment YE and the segment ES, notice that they both share the same letter. If you were then to look at the diagram and mark it up, you would see that angle E is the included angle. It's in between. If we look at the middle segments, we've got ES and YS. Notice that what those 2 share in common is S, so that would be the included angle. The last set of segments here are YS and YE. Notice that they share the similar letter of Y, so that's why angle Y would be the included angle. So the angle that's in between my 2 segments. All right, now we're going to look at the pictures and we're going to find the included side from each picture. So based off of the 2 angles that are marked on the far left, notice that it was angle I and angle G. So the segment that's in between them, you just put the 2 letters together. Notice that that would be segment GI, or you could say segment IG. If we look in the middle, we got angle I and angle H that are the angles that are marked. So the segment in between, segment HI, or you could have said IH. In the last one, based off of the two angles that are marked, notice that my segments would be GH, or you could say HG. So now I want to find the included segments, find the included side. So based off of the two angles, angle Y and angle E, all we have to do is put them together, and that's my included side. If I look at then E and S, those two angles, the included side, segment ES. And then finally, if it's angle S and angle Y, you put them together, the included side is the segment SY. All right, notice that we just talked about 4 ways in which you could prove congruent triangles. I cannot stress enough the ways that you cannot prove congruent triangles. So no way did we ever have a combination where we had angle side side or side side angle. Look at how the spelling is. It spells out the word ass, okay? Or it spells out the word ass backwards. Don't ever spell out a swear word in math, please. This is a no-go. Please do not try to prove congruent triangles that way. That's the only time you'll ever hear me swear. Do not spell out the word ass. Okay, the other way that we cannot prove congruent triangles would be angle, angle, angle. Okay, all 3 angles in a triangle are not going to prove triangles congruent. Okay, that's something that we'll talk about later on down the road, and that means something else. It doesn't prove congruent triangles, though. All right, so we're going to look at all these diagrams, and we're going to name the postulate. So remember the postulates that we talked about to prove congruent triangles: side, 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 angle, side, angle, side, angle, or angle, angle, side. Those are the only 4 ways that we could actually prove that triangles are congruent. So if I look at the upper left-hand triangles, if we look at the markings, notice that we've got, let me highlight them as I talk. We've got a side that's marked, then we have an angle, and then we have another side. So hopefully we're okay with then. That's side, angle, side. If I look at the top right, we start with a set of angles. Notice how there's one tick mark there, one tick mark there inside the angle. Then we have a segment followed by another angle. So notice how that turns out to be angle, side, angle. If I look at the bottom left, notice that we've got a side, then another side right next to it, and then an angle. Notice that that angle is not in between the 2 sides, okay? So that spells out ass backwards. We can't have that. That is not a way of proving congruent triangles. So this one I would say, oh, let me write out with a pen. This one is not possible. Okay, if we look at this last picture here, notice that we've got a set of sides, a set of another sides, a third set of sides. So this one, side, side, side. Let's take a look at some more. We're going to name the postulate if possible. Okay, so I'll write them again at the top. If my pen will let me. Here we go. Okay, remember we've got side, 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 angle, side, angle, side, angle, or angle, angle, side. So if I'm looking at my first triangle in the upper left, we've got an angle, followed by another angle, followed by a third angle. So notice that that's angle, angle, angle. That is not one of those ways that I can prove the triangle's congruent. So once again, this one is not possible. Looking at the top right, we've got an angle, a segment right next to it, another angle right next to that. So we've got angle, side, angle. That is a way to prove the triangle's congruent. The bottom left, we've got a set of sides, an angle that's right next to it, another set of sides. So notice that this one is side, angle, side. That is a way to prove the triangle's congruent. Bottom right here, notice that we've got a set of sides right next to it, another set of sides followed by an angle. So when we have side, side, angle, remember, spells out a bad word. This one is not possible. All right, let's look at some more. Notice that in these pictures, I only see two things that are marked. That's a problem. In order to prove congruent triangles, notice how I have side, side, side. I have three things. Or side, angle, side, three things. Or angle, side, angle, three things. Or angle, angle, side. So we have to have three things congruent in order to prove the triangle's congruent. But just because I don't see three things marked doesn't necessarily mean that we don't have three congruent pieces. If we look at the top left, notice that these two triangles are sharing a side. And so if they share a side, remember, that's congruent to itself by the reflexive property. And so I do technically now have three things marked in my picture. So with the reflexive property, notice that we've got a set of sides, followed by an angle right next to it, followed by another set of sides. So we have side, angle, side here. We do have a way of proving the triangle's congruent. If we look at the top right, notice that we only have two things. But if you notice that how these triangles are positioned, we have vertical angles. And remember, vertical angles are congruent. So I do have three things marked in my triangles. Notice how we've got a set of sides, an angle that's right next to it, followed by another set of sides. So we've got side, angle, side again. If we look at the bottom left, notice how only see two things, but how it's positioned. We have, once again, vertical angles, and vertical angles are congruent. So now that we've got three things, we've got a set of sides, an angle that's right next to it, another set of sides. So notice that that gives us side, angle, side. I promise you, not every single thing is going to give us side, angle, side. It just happens to be so far. Okay, if we look at this fourth one, notice how I see two things that are marked. So I need a third thing. Well, these two triangles are connected through a segment. So I've got the reflexive property here. We can have a segment congruent to itself. So notice that we've got one segment, we've got two segments that are right next to each other, followed by an angle. So a side, and an angle. But remember, that spells out a bad word. And so this one, even though we have the reflexive property, which gave us three things, this one is not possible. Okay, so pause the video, see if you can come up with how these triangles are congruent if they are. All right, so hopefully you saw with the top left, we have the reflexive property, which then gave us side, side, side. In the next one, I don't have vertical angles, okay? These angles up here, while they have the same vertex, they are not directly across from one another. So I don't have vertical angles, which means I don't even have a way of getting three markings. And so that's why that one's not possible. If I look at the next one, I have three markings, but I have two sides and an angle right next to it. So that one is not possible. And then here we've got three angles. Angle, angle, angle is not possible. Go ahead and pause the video again and see if you can come up with my answers for these two pictures. Okay, so hopefully on the left, you saw that we had vertical angles. And so then based off the markings of the picture, we now have angle, side, angle. And then by using the reflexive property for the one on the right, we have three markings, but it gave us side, side, angle. So that one is not possible. All right, so let's indicate the additional information we're going to need in order to enable us to apply the specific congruence postulate. So if I look at the two triangles that are marked, there's only two things. Remember, we need three things congruent in order to say that we have congruent triangles. So in this top example, I want to prove those triangles are congruent by angle, side, angle. Notice that one side is in my picture that's marked, one angle is in my picture. So what happens to be missing? Well, another angle is. So what I have to do is I have to name the angle that would make the side sandwiched in between. I want that to be the included side. So hopefully we notice that would be angle B congruent to angle D. Okay, that makes the segment in between the angles. So then my next problem here, I want the same picture, but I want to have the triangles congruent by side, angle, side. So notice that we have one side that's already marked up. We have the angle, it's missing a side. So we need to pick the side that is going to make the angle the included angle. And we have to name our segments correctly. Okay, hopefully we notice that would be the segment AC and FE. Notice that C and E have to be in the same spot in my segments because those two angles are marked the same. So now here I want to prove that these triangles are congruent by angle, angle, side. Notice that we have one angle and we have one side. So it looks like we're missing an angle. But I need the angle to make that side not included. So that means it would have to be angle A congruent to angle F. Okay, so now you pause the video and you try using the picture to see if you can come up with how to prove the triangles congruent by angle, side, angle, by side, angle, side, and by angle, angle, side. All right, so hopefully with the first one, you came up with angle N congruent to angle V. It was missing the angle and it needed to make the side sandwiched in between to become the included side. For the side, angle, side, if you have the M and the K switched around, that is perfectly fine. But then that means that the U and the T would have to be switched around as well, because notice how K and T are marked the same. K and T have to be in the same spot. And then in the last one, it should have been angle M congruent to angle U. So that's us proving triangles congruent using our 4 postulates.